Good day, ladies and gentlemen, personalities. Today we are speaking about general equations in trigonometry. Right? So what will happen is that you will be asked to find the general equation. What is a general equation? A general equation is an equation that helps you find solutions that are in different quadrants. Right. Okay, so let's say, for example, they say find the general solution of sine theta is equal to 1 over 2. How do you deal with that? Okay, so you will need to know how to find a general formula of sine in general. Now, how do you go about finding a general formula of sine? Yeah, how to find general solutions. Okay, I'm going to help you and give you a guideline for 3 trigonometric functions, which is sine theta, cos theta, and tan theta. Right. So, for example, if you have sine theta is equal to a, right, then remember we had something like this, SATC. Okay, so you had all trigonometric functions being positive here, only sine theta being positive here, and then only tan theta being positive here, and then only cos theta being positive here. All right, so you've been given sine theta, which is equal to a. All right, so a in this case, it is positive, right? So since you know that sine theta is only positive where? In the first and the second quadrant. That means that the general solutions will also be the generators of the general solutions. The generators of solutions, which is the general solution, will be found where? In the first quadrant. There will be a generator in the first quadrant, and then there will be a generator in the second quadrant. So how do you find those generators? The first generator is that, so in quadrant 1, what will happen is that theta will be nothing other than the reciprocal, okay, the reciprocal of a function of sine, which is evaluated at a, and then plus 360 degrees n. Or the other solution will be in a second quadrant. Let's say quadrant 2. Okay, so what is the solution? You remember the solution in quadrant 3 is 180 minus. Okay, so what is gonna be? So you're gonna have theta, which is equal to 180 minus the reciprocal of sine theta, of sine evaluated at a, and then all of this thing plus 360, and then basically this n is integers. Okay, let us do an example. You've got sine theta, which is equal to half the one that you are given here. So how do you find a general solution here? Okay, we said general solution here is going to be in quadrant 1 and quadrant 2. Okay, so what you're going to do is you're going to find a reference angle, because this is a reference angle. Okay, so theta ref is equal to the reciprocal of sine evaluated at 1 over 2, which is equal to 30 degrees. Okay, this is the reference angle. Okay, you're gonna use this reference angle to find the general solution in quadrant 1 and the general solution in quadrant 2. So how to do that? You say in quadrant 1, quad 1. Okay, so you're gonna have theta, which is equal to 30 degrees plus 360 degrees. And then what about quadrant 2? In quadrant 2, you're going to have theta, which is equal to what? Which is equal to 180 degrees, minus what? Minus 30 degrees, and then plus 360 n. Okay, and then 180 degrees minus 30 is going to be 150 degrees plus 360 n, and then you've got n, which is equal to, which is an element of integers. So what do these solutions mean? It means that the solutions in the first quadrant will be generated by this one, okay. Some of the solutions will be generated by this one, some of the solutions will be generated by this one. So they say here n is an element of integers. What are integers? Integers is 0, it's 1, it's minus 1, it's 2, it's minus 2, and so on and so on. All right, so n is equal to 0, and then plus or minus 1, plus or minus 2, and so on and so forth. Okay, so when you are having a general solution, you can actually use this general solution to find particular solution by keeping on substituting these values of n, which is 0. For example, if you substitute 0 here, what do you get? You get 30 degrees, right? And then sine 30 degrees, we all know that that is equal to half. Okay, and then let's say you put 1. If you put 1 here, you're gonna have 360 plus 30, which is 309. Now, what is sine 390? Sine 390 is equal to what? Is equal to half, which means that it is true. It does give us solutions. What about minus 1? Let me just test 1 minus 1. When you put minus 1, it's going to be 30 minus 390, which is minus 330. Let's check sine minus 330. What happens? You get exactly half. That means that this is able to generate you some solutions. Now, what about this one? When you add 0 here, you're going to remain with sine 150. And then we all know that sine 150 degrees is equal to what? Is equal to half. And then when you add minus 1, you can check yourself. You will see. So basically, this generates some of the solutions, and then this will also generate some of the solutions. And then this one and this one will give all the solutions that fit this graph. Okay, so this is how you deal with sine. Right. Now, what about cos? If you've got cos theta, which is equal to what? Which is equal to this, also take half. How do you find general solution? The question will always be specific. Find general solution of, and then they will give you this one. So how to do that? So if sine theta, if cos theta is equal to, say, something positive, let's call it A this time around, then your theta, you will have a solution in, okay, let's look at cos. All stations to Cape Town, or all students take coffee. Okay, so cos is positive where? In the first quadrant, and what? And then in the third quadrant. So you will have quad 1. Now in quad 1, what are you going to have? You're going to have theta, which is equal to the reciprocal of cos evaluated at A, which is this value that you have here, and then plus 360 n, and then you will have a solution in quad 3, which is what? Which is what? Which is theta. In quadratic, as you know, it's always 180 plus. Okay, so which is equal to 180 plus what? So you've got 180 plus we're talking nonsense. Okay, we've done quadrant 1. No, guys. We are talking nonsense. It's not quad 3. Cos is not positive in quad 3. It's positive in quad what? In quad 4. So theta is going to be, in quad 4, you've got 360 minus. So you're going to have theta, which is equal to 360 degrees minus what? Minus cos. Evaluated at A. The reciprocal of cos evaluated at A. But all of these things, guys, you're still going to say plus 360 n. And then you've got n, which is an element of what? You've got n, which is an element of integers. Okay, the second example, we've got cos theta is equal to half. Let's find the reference angle. Cos theta is equal to half. So the reference angle here is theta is equal to the reciprocal of cos evaluated at half. And then what do we get there? We get 60 degrees. You can check it on a calculator at 60 degrees. And then when you say cos 60 degrees, you must get half. Let's see if we're not talking nonsense. Cos 60 degrees, you do get what? You get half. Okay, so now we said we have solutions in quadrant 1. So the general solution in quad 1 is nothing other than, so we've got theta, which is equal to what? Which is equal to 60 degrees plus 360 degrees. And or you've got another solution in quad what? In quad 4, which is what? Which is theta is equal to, you've got 360 degrees minus 60 degrees plus all of this plus 360 degrees n, and then you've got n, which is an element of integers. So that basically what? 360 minus 60, it's 300. So we've got 300 degrees plus 360 n, and then n is an element of what? Is an element of integers. Okay, you can keep on adding 0, 1, minus 1 and see if the solutions are correct. Okay, now let's do the last one. The last one, let's say we've got tan theta, which is equal to 1 over root 3, and then you are supposed to find a general solution here. So how do you go about finding general solutions here? Okay, so how to find a general solution here? Now, if you have tan theta, which is equal to A, now theta is very different. Theta is equal to the reciprocal of tan evaluated at A, and then you've got plus 180 n, and then n, which is an element of integer. So here you don't have two generators, you've got only one generators. So for example here, since we've got tan theta, which is equal to 1 over root 3, so you will find a reference angle, which is theta ref, and then which is the reciprocal of tan evaluated at 1 over root 3, and that gives you what? 30 degrees. You can check it yourself on your calculator. And then, so your general solution will then be theta is equal to 30 degrees plus 300, so not 360, but 180 n, and then you've got n, which is an element of integers. Okay, do you understand? So when it comes to tan, it's only one generator, but when it comes to sine and cos, there are generators that comes from quadrants where that particular trigonometric function is positive. So ladies and gentlemen, personalities, thank you so much for tuning in, and thank you.